Waves. Waves transfer energy from one place to another without moving matter. When a light wave travels from a phone screen to your eye, or when a sound wave travels from a speaker to your ear, the particles in the medium oscillate but do not move along with the wave. Only the energy is transferred, not the medium itself. Similarly, imagine a floating ball on a water wave. The ball moves up and down but does not travel with the wave. The wave vibrates or oscillates. From displacement distance graph, the distance shows how far the wave has traveled from its starting point, while displacement shows how far the wave oscillated from its equilibrium point or mean position. Definition of amplitude. The maximum displacement from its mean position is called amplitude. Definition of wavelength. The distance of one complete wave or oscillation is called wavelength. SI unit of wavelength is meter. It is denoted by lambda. You observe displacement time graph by taking time on x-axis. The distance of one complete wave or oscillation is called time period. Definition of time period. The time taken to complete one complete wave or oscillation is called time period. SI unit is second. Definition of frequency. The number of waves produced in unit time is called frequency. SI unit of frequency is hertz. Definition of wave velocity. The distance traveled by a wave in unit time is called wave velocity. SI unit is meter per second. Relation between wave velocity, frequency, and wavelength. According to the definition of wave velocity, v is equal to distance traveled by a wave by time. But distance traveled by a complete wave is called wavelength lambda. Substitute in equation, we get v is equal to lambda by t. 1 by t is called frequency. The number of waves produced in unit time is called frequency. So the equation can be written as v is equal to n lambda. Waves are classified into two types: mechanical waves, electromagnetic waves, or EM waves. Mechanical waves require a medium to travel. Electromagnetic waves do not require a medium to propagate. Here we will discuss only mechanical waves. Types of mechanical waves: transverse waves and longitudinal waves. Transverse waves. If the oscillations of particles are in y direction and motion of the wave is in x direction, we call it transverse wave. The angle between oscillations of particles and wave motion is 90 degree, or they both are perpendicular to each other. For example, consider the waves produced in this lanky spring. Your hand moves up and down in y direction, while the wave moves in x direction. So it is an example of transverse waves. Transverse waves are made out of consecutive crests and troughs. The part of wave above mean or equilibrium position is called crest, while the part of wave below the mean or equilibrium position is called trough. The distance between consecutive troughs or crests is equal to wavelength lambda. Definition of transverse wave. Displacement of particles move perpendicular to the direction of the propagation of wave is called transverse waves. The example of transverse waves are water waves and electromagnetic waves or EM waves like X-rays, radio waves, light waves. Now we will discuss about longitudinal waves. If the oscillations of particles are in x direction and the motion of wave also in the same direction, we call it longitudinal wave. Note down that in longitudinal waves, the angle between oscillations of particles and motion of wave is 0 degree, and they both are parallel to each other. For example, consider the waves produced in this spring here. Your hand moves back and forth in x direction, while the wave also moves in the x direction. So it is an example of longitudinal waves. Longitudinal waves are made out of consecutive compression and rarefaction. The region of relatively high density and pressure is called compression, while the region of relatively low density and pressure is called rear friction. Definition of longitudinal waves. Displacement of particles move parallel to the direction of the propagation of wave is called longitudinal waves. Examples: sound waves and ultrasound waves. Thanks for watching Pathfinder 6. Like, comment, share and subscribe to my channel.